Hello, now we are going to talk about how to find the angles between two planes. Alright, so if we have two planes and we're going to need both the normal vectors of both planes to be able to figure this out. So if we have a normal vector n that's perpendicular to this plane, normal vector m that's perpendicular to this plane, then we can find the angle using those two normal vectors to find the angle between the planes. So to see how this works, we're going to go ahead and draw a picture to see if we can derive it. So let's draw two planes, right? And let's think of two planes intersecting, and we're going to try to find the angle between them, theta. So that's right there. And then I'm just going to try to extend this out so you can see what's going on here. So here are the two planes. Hopefully you can see that pretty good. Now let's try to draw the normal vectors. Let's say here's one normal vector that comes up. Just easier to see if we see it right on the edge, and that's there. I'm going to call that n. And then if we try to draw the other one, m, that's the normal vector m right there, right? Now let's see, and that's perpendicular, so it kind of looks like it's in this plane, but you could tell these two are going to intersect at these points right here. Now if this is theta right here, and this all the way to here is 180, so this angle from here is 180 minus theta, right? So from here to here is 180 minus theta. And if you notice, we make a quadrilateral right here, right? And all quadrilaterals add up to 360 degrees, right? But we already have two 90-degree angles, so that's 180. So these two angles right here have to add up to 180 degrees. So if that's the case, this has to be theta. That angle has to be theta, right? That's in between them, right? So and you can check that out, right? This plus this plus this plus this will all come out to, that cancels out 180 plus another 180, 360 degrees. So that works out. So to find the acute angle between these two planes, we just find, you know, the dot product of the normal vectors of the two planes, right? And that gives us this property right here, and it says the angle theta between the plane with normal vectors m and a plane with normal vector n is equal to the angle between the lines in the direction of the vectors m and n. It is given by the theta is the arc cosine absolute value of the dot product over the magnitudes of the normal vectors, right? And theta is between 0 and 90 degrees, so that gives us our 90 degree, our acute angle right there. So let's go ahead and look at an example so we can use this. So example 43 says find the angle between the two planes, and that's what we're going to do. So the first one, it's equation of the plane, right? So we know the coefficients make that normal vector. So that first normal vector is going to be the 2, negative 1, 1, right? Now this one's a little trickier. If we look at r, right, that would, if we put that in vector form, that would be 1, 2, 0, right? 1, 2, 0 plus alpha, the vector in this would be negative 1, negative 3, and 0, plus the beta form, which would be 1, 0, 2, 1, 0, 2, right? Now, those are the two vectors that are in the plane that I have there, but I need to find the normal vector of that, right? And to find the normal vector, we'll call it m. I'm going to have to take the cross product of those two vectors to find the normal vector to that plane. So I'll have to take negative 1, negative 3, 0, cross product 1, 0, 2, right? And what's that going to be equal to? Well, if I put my hand over here, it's going to be negative 6 minus 0, right? The middle term would be 0 minus a negative 2, positive 2. And then the last one would be 0 minus positive 3. And there you go. So that is my normal vector. Good. And now that I have the two normal vectors, now I can go ahead and find the angle between them, right? And it's going to be the cosine inverse of the absolute value of the dot product up here. So it's going to be negative 12 minus 2 plus 3, and then it's going to be over the square root. This would be 4, 5, 6. The square root is 6. Yep. Times the, let's see, square root of 6 squared is 36 plus 4 plus 9. And then I can go ahead and put this into my calculator to see what it comes out to be. So I'm going to and so I'm going to go sine, I'm going to do cosine inverse. I'm going to need the absolute value, and I'm going to need a fraction form right here, and I got negative 12 minus 2 plus 3 all over the square root of 6 times the square root of 36 plus 4 plus 9. And I hit enter, and I get approximately 50.1 degrees. So theta is equal to 50.1 degrees approximately. And there you go. Thanks, guys.